Good evening, sir, and also good evening for my batchmates. I am Tejaswiti. Today I am teaching the lesson Electromagnetic Waves. In this chapter, we are going to study electromagnetic waves and also electromagnetic spectrum. Electromagnetic spectrum. Before going to this chapter, we will learn some of the basic concepts and also the applications of this. Yes, sir. What are the things we can see around us? We can see everything around us, right? Yes, you are seeing the board and also the duster, and also in your surrounding also you can see some of the things in your study room, right? Like that. But we are failed to see some of the things. We cannot feel that also, but we are immersed in that. That is most important. We are immersed in that, but we cannot seeing that thing. The strange thing is electromagnetic waves, which can propagate in vacuum also with a speed of light, right? Then we will learn about electromagnetic waves in a most interesting way and also with knowing the applications in our daily life. So let's dive into the chapter electromagnetic waves. Before diving in, one thing I have to inform you that you tell your brother or sister to turn on your hotspot. I have to use Wi-Fi. The thing is, do you ever observe, thought that what are the connection between hotspot and Wi-Fi? Is there any physical connection between them, or is there any wire between them? No, there is no any wire between them. But you can use that data without even feeling the any physical things between them. That is electromagnetic wave. That's the power of electromagnetic wave. We are used to watch our TV and also use your remote sitting 1 minute something some meter away, and you can operate that TV in your sitting only, and also you can seeing me on your screen. That is because of electromagnetic wave. So seems interesting, right? This chapter is so much have interesting things to be known. So let's go to the electromagnetic waves. First, we have to learn about the introduction of this chapter. We are aware about the fact that magnetic field changing with time give rise to an electric field. Yes, in the fourth chapter, we have studied that change in magnetic field or a magnetic field changing with time give rise to electric field. And also in the EMI chapter, also change in magnetic flux linked with the coil produces an EMI, electromagnetic induction. Okay, is the converse also true? Can we produce magnetic field from an changing electric field? We don't know still. We have studied that some of the things, but we do not know about the converse thing. Okay, does electric field changing with time gives rise to magnetic field? This is question mark. We have to study about this in this chapter only. Okay, Maxwell noticed an inconsistency in the Ampere circuital law. First of all, what is Ampere circuital law? Ampere circuital law. We have studied this in moving charges and magnetism, right? Can anyone answer in the chat box? What is Ampere circuital law? Or you can type the formula also. Okay. As many have said, Ampere circuital law means the line integral of B dot product of dl is equal to mu naught I enclosed. What is meant by I enclosed? I enclosed means the current enclosed in the loop while applying. But Maxwell observed is inconsistency in this formula. Till now we have studied that line integral of B dot dl is equal to mu naught I enclosed. But Maxwell find inconsistency in this formula. What is the inconsistency? We will know about that. While applying the Ampere circuital law to find magnetic field at a point outside the capacitor connected to a time varying current, he suggested the existence of an additional current called by him displacement current to remove its inconsistency. He removed this inconsistency also. In few minutes, we are going to know about that. What is that? Ampere circuital law is used to find the direction and sorry, you have to use the vector notation also. Sorry for that. We have to find the we will find the magnetic field and magnetic field direction by this formula. Okay, but in this of Ampere circuit law, there is inconsistency. Who proposed that? Maxwell proposed that. What is that inconsistency? Let me explain that. In capacitor, if it is uncharged, and if we place a loop between the capacitors, then line integral of B dot dl, that is Ampere circuit law, is equal to mu naught I enclosed. Here in this case, what is the I enclosed? Can anyone answer? What is the I enclosed in this loop? Yes, according to the answer, I enclosed is equal to 0. Therefore, the Ampere circuit law becomes B dot dl is equal to 0. Okay, this case is correct. Maxwell also obeyed this experiment. Next, when the charges are deposited on this capacitor, and the equal charges are deposited in this capacitor, then B dot dl is equal to 0. Here also Maxwell obeyed that B dot dl is equal to 0 when the current is not changing and the charge distributed over them is equal. Then here the strange thing comes, and Maxwell proposed the word a new thing, that is electromagnetic waves, which we are using in our mobile. Till now we are using mobile phones. We are connecting to the data. That is because of electromagnetic waves. So Maxwell turned around the world with a new technology by introducing electromagnetic wave, by finding the inconsistency in this formula. Let's study about that. Here, Maxwell connected this capacitor to the battery, and he put the loop between the capacitor, and when the current is flowing through it, the electric field is changing through it. Then he observed that B dot dl is equal to, can anyone tell what is that? Okay, I will tell only. B dot dl is not equal to 0. This made the inconsistency for the Ampere circuit law. What's that inconsistency? He found out that here data displacement current to remove its inconsistency. He proposed displacement current, then the formula fits very good. That is B dot dl is equal to mu naught epsilon naught d phi by dt. d phi by dt. d phi by dt. In which chapter we have learned about this? Yes, sir. Yes, sir. In EMI chapter only, we learned about this d phi by dt, change in magnetic flux with respect to time, produces an voltage that is linked with the magnetic Ampere circuit law. Here, what is here we told you put displacement current. Displacement current means here epsilon naught d phi by dt is called as the displacement current. What is ID? We can represent that as ID, D as subscript. ID is equal to epsilon naught d phi by dt. In the by introducing this, he linked the magnetic field with the EMI and proposed give a signal for the new world about new technology. Okay, thanks.